Hello and welcome back to this video. And in this video we are going to find the derivative of sin x and cos x using first principle. Can you go ahead and like this video? Okay, let us begin. So we recall that we said that in the video 1 that using the first principle, f prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x, all that on h. So we are now going to start with the first example where f of x equals to sine x, and this is a trigonometric function. So we will now say that we'll be having our f of x equals sine of x, and our f prime of x will be equals to the limit as h goes to 0 of the sine of x plus h minus sine of x, all that, I can put this in bracket, all that on h. This is just what I've just substituted in this formula. Okay, so if you do that, you simply got this. And the next thing we're gonna apply here is we will do a little mathematics in it, and we'll apply what they call double angle formulas, okay, in trigonometry. And the formula, I will also give you the formula. It says that sine of a minus sine of b is equal to 2 cos of a plus b on 2 multiplied by sine of a minus b on 2. So this numerator here of our fraction, we'll then write it gently or neatly in this manner. And to apply it, we need our a plus b. What is even our a? By comparing it, sine of a, our a will be equal to x plus h. Just looking from here. And similarly, our b equals x. We see it from here, okay? And a plus b will be equals to x plus h, then plus x. This x here is for b, while the other one, x plus h, is for a. And if we add this, we get x plus x is 2x plus h. Then we need again a minus b to complete. So we'll be having a minus b will be equal to x plus h minus x. And this x now is for our b, and this x and this x cancels, we are just left with h. X plus h minus x gives us h, and we cannot neatly write our limit in that with this trig identity. So we are now going to say that our f prime of x will now be equal to the limit as h goes to 0 sine 2 instead cos of a plus b on 2, which is now 2x plus h on 2, sine of a minus b, this is the formula, sine of a minus b on 2, sine of a minus b on 2, which is h on 2. And don't forget, this one we are divided by h, we just substituted by the numerator without the h. Okay, so if we continue with this, we'll now simply see that our f prime of x will be equal to the limit as h goes to 0 2 cos of 2x on 2 plus h on 2 sine of h on 2. I can just separate this and dividing each term by the 2 that they're sharing, that is like fractions. Okay, you can add them back and have back the same denominators, and all this is on h. And if you simplify this, you see that these 2 can cancel, and we now get limit as h goes to 0 2 cos of x plus h on 2 sine of h on 2, all that on h. Okay, and now the next thing again we're gonna do here is simply, I want to take this 2 and put it down here. But how can I do that, and why am I going to do that? The first reason I'm going to do it because in limit from as h goes to 0 of sine of h on 2, all that on h on 2 is equal to 1. But I have h on 2 here. Okay, I need h on 2 also bottom here. But how am I going to do it? By simply taking this 2 and bring it here. And it is possible in math. Recall that a on b on 2 is equal to 2a on b. Okay, that is I can multiply this by 2, the top and denominator by 2, and these 2 cancels. So this is the same thing I'm going to do here. I will take this 2 and bringing it here. Bringing the 2 here is same as the 2 can bringing the 2 here is same as I can still multiply this by 2, multiply the numerator by 2, and this 2 cancel and the 2 goes back. So I will just simply bring the 2 down neatly. Any questions, please ask in the comment section in this video. Okay, now we will simply be having limit as h goes to 0. We will now be having cos of x plus h onto sine of h onto all that on h onto. Okay, these 2 can still come here, please. Okay, now from limit theorem, limit of product is same as limit of a multiplied by limit of b. So we can go ahead and apply it. That is maybe as this x goes to maybe 0, or x goes to 0, x goes to 0. It's like that. So limit theorem, limit. So this is our a and b. So I'm going to divide this limit. So we'll now be having limit as h goes to 0 of cos of x plus h onto multiplied by limit as h goes to 0 sine of h onto. But I'm just trying to put the h onto here, put here 1, bearing in mind that I can still multiply this by this, I still get back common denominator h onto. Okay, but now this limit here is equals to 1, so we now get limit as h goes to 0 cos of x plus h onto multiplying by 1. Wow, and we are almost done. I'm now going just to substitute h as 0 in this value, so we now just get cos of x plus 0 onto multiplied by 1, and we just simply get cos of x plus 0 multiplied by 1, and this simply gives us cos x plus 0 is x multiplied by 1, and we just get cos of x multiplied by 1 is just cosine of x. So we have shown that our f prime of x is equals to cos x. Have you been hearing about it? So this is how it was proven. And since we are short of time, I wanted to derive the formula for the cos of x. That is, if f of x equals to cosine of x, then our f prime of x is equal to negative sine of x. Wow. Okay, so this is now how to find this. So the exercise I'm going to give to you, that you are going to submit to our WhatsApp forum where we help all students within Africa, you are just going for free. We are helping the students for free. Please don't pay anything. So to join, you just simply need to write on WhatsApp 651684870 plus 237 on WhatsApp, please. Okay, now my country code is plus 2376. I'm from Cameroon. Okay, now this is the number. Now to find the derivative of this other one, you also use same first principle. You'll be saying that limit as h goes to 0 cos of x plus h minus cos of x, all that on h, and then you also apply the factor formulas and you simplify this. You also do that and you simply get negative sine x. Can you go and give this a try? So feel free to do. If you didn't succeed, you comment on the section below and give this video a thumbs up. And if the video is very helpful, consider subscribing to the YouTube channel, share to your other brothers and sisters, and let us continue to embark in this learning journey. Have a great day, and thanks for subscribing to the YouTube channel.